Immunoassays are widely used tools for detecting small molecules. Immunoassays enable measuring the presence of a specific molecule or even the relative amount of a specific molecule in a solution. This can be useful in many cases, for example, when diagnosing diseases or detecting toxins from the environment. But how is the detection of specific molecules possible? Immunoassays are based on the specific detection ability of certain proteins that are called antibodies. In a similar way that how only one shape fits into a certain hole of a shape-sorting puzzle for kids, only a certain type of compound can bind to a certain antibody. This means that the binding reaction of a compound to an antibody is highly specific. The specific compounds that bind to the antibodies are called analytes. The analytes are either proteins or other kinds of molecules. The analyte is what we want to measure in the solution. To be able to detect the analyte, it needs to be labeled with something that can be measured. After the analyte has bound to the antibody, it can be labeled, for example, with fluorogenic reporters or enzymes that produce an observable. This makes it possible to detect if the analyte is present in the solution with bare eyes. Why are immunoassays then so important? Immunoassays are widely used for different medical tests and therefore have a great clinical significance. They are used for identifying markers to help in diagnosing various diseases, such as AIDS and cancer. The early and specific detection of such diseases is vital as the treatment can be started early by the healthcare professionals. The most known immunoassay must be the pregnancy test, which is also a significant invention. The pregnancy test detects a hormone that is produced by the placenta. Immunoassays also contribute to the quality control and safety of our food supply. They are used in food industry to detect antibiotics, pesticide residues, and microorganisms. Immunoassays are also used for environmental and forensic purposes. They can be used to detect toxins that are produced by bacteria in oceans and lakes. Police forces and other actors use immunoassays, for example, to investigate crime scenes and to detect doping among athletes. There are countless applications for immunoassays and a lot of ongoing research. Only the future will tell us what can be achieved with immunoassays.